Okay, here we go. So, number one, we're supposed to find the inverse of the functions. So that's where we run through those steps. Step one is change f of x to y. Step two is to switch x and y. X equals -6y. Okay, and then finally we solve for y. So I'm going to divide by -6 on both sides. That'll cancel these out. We'll be left with x over -6 equals y. And then we just want to use that new inverse notation. That's where we use the little -1. So f inverse of x equals x over -6. All right, next problem. Don't get thrown off that they're using a g instead of an f. It's the same process. Switch g of x with y. Then switch x and y. And then we begin solving for y. I'll subtract 2 on both sides. Over here, that's going to give me x minus 2. Bring down my equal sign. These 2's are gone. Still have a 5y. I can divide by 5 on both sides. These 5's are gone, and then I have x minus 2 over 5 equals y. So now y is solved for, and we just use that new inverse notation. So f inverse of x. We could use g here, actually. That might be more appropriate, but we'll just stick with this. And then, as always, it's a good idea to box your answer. I realize I'm moving kind of fast, but you'll have access to this soon enough. So, okay, so now we're on to composition of functions. That's what we practiced yesterday, so this shouldn't be too new. So we always want to look at the first letter, the outside function, or I was calling it the main function yesterday. In this case, it's f. So we're going to go ahead and copy f down, but anywhere there's an x, we're going to leave it blank and put some parentheses there. So f, leaving the x out, equals 5. And then I'm going to leave this x out. I'm going to put some parentheses in its place, and then plus 2. What I put into these blank spaces is whatever the inside function is, or whatever's in that place. In this case, it would be the g function. So the g function is right here. It equals x minus 8. So x minus 8 is what I'm putting into the blank spots. So I'm going to put x minus 8 here, and then x minus 8 here. That's the hardest part of doing this, of doing compositions, in my opinion. You should simplify if you can. The left side always stays the same. So f and then x minus 8. We can simplify by distributing. So that's going to give us 5x. And then we also need to multiply the 5 and 8. That's going to give us minus 40. And then we bring down this plus 2. And then finally, we can put negative 40 and 2 together. So negative 40 plus 2 is 38. So minus 38. Five x minus 38. 38. Are these functions inverses? No. How do you know? Let's say because f of g of x does not equal, we'll use that equal with a slash, does not equal x. Remember, it has to equal x in order for them to be inverses. All right. Now we're going to do the composition the other way, where g is the main function or the outside function. So we're going to have g. Remember, step 1, I just write out the g function, but wherever there's an x, I have a blank spot there. Then I look at the inside function, which is going to be f of x, and that's what I fill in with the blank spots. So f of x is 5x plus 2. So in each blank spot, I'm going to put 5x plus 2. All right. Again, that's the hardest step. That'll get you a lot of points on the test if you can get that far. And then if you can simplify, go ahead. In this case, there's nothing outside the parentheses, so we can act like they're not there. And then we can add 2 and negative 8 together. 2 and negative 8 is going to be negative 6. So we're going to have g of 5x plus 2 equals 5x. And then instead of writing 2 and negative 8, we're writing minus 6. So are these functions inverses? No. They're not. Again, this one equals 5x minus 6. The only way they would be inverses is if it was equals x. Maybe we'll write that a little differently this time, how we know. We'll say when the two functions are composed, they do not equal x, or they don't equal x. Either explanation is the same. This one's more wordy, but either one would be fine. All right, on to, let's see, number 5. So graphing linear functions in their inverse. All right, so this one is like that worksheet where we look at the graph of the two functions and we have to decide if they are inverses or not. Okay, so what we want to do is we want to look at the line y over x. And if you remember, that line starts at 0 and it goes up 1 over 1, up 1 over 1. And you want to draw as straight as you can. And then visually, this is more of a visual test. You're asking yourself if they look symmetrical about that line, y equals x. So if they look symmetrical over this line, meaning they're a perfect reflection of each other, then they are inverses. So are they inverses? Yes. How do we know? Because they are symmetrical. I might have two M's in it, but it's okay. They are symmetrical about the line y equals x. So all I got to do is draw in that line and then look if the two functions are symmetrical. Okay, for B, let's do this one. So again, we'll draw in that line. Usually it's dashed because it really represents like an imaginary line. It's not actually a part of the graph. There's our y equals x. Visually, these are not symmetrical. They're not exactly the same on both sides of the line. And so that's enough for us to say no, they are not inverses. How do we know? They are not symmetrical I think it is two M's. I'll look it up after this. They're not symmetrical about y equals x. Okay, so that's all I got to do for these ones. Okay, domain and range. Okay, so remember the domain deals with the x values, and we read the graph. We look at the x values from the left side to the right side. The range deals with the y values, and we look at the graph from the bottom to the top. Okay, so here's our first graph. We want to do the domain. So on this graph, we're only looking at these values for the domain. Okay. So it looks like right here, the farthest left point of the graph is going to be at -3, and it's a solid dot. So a solid dot gets a square bracket. So we start at -3. And then we look to the farthest right spot of the graph. The farthest right spot of the graph is right here. I can't go any more right than that. And that matches up with 3, and it's a solid dot. So a solid dot gets a square bracket. So the domain goes from -3 to 3. Okay, next is the range. So range, we would only be looking at these numbers because they represent the y values. So we go from bottom to top. So the farthest down we can go is right here. And if it's right on the graph, we consider that a square bracket. So that looks like that goes with -5. And then we go up as high as we can go to the top. The graph doesn't go any higher than 4 right here. And there's solid dots. So the range, so we would use a square bracket to close. The range is from -5 to 4. All right, next one. So domain, again, we're only looking at these values, the x values, and we're looking at the graph from the left side to the right side. So it looks like this is as far left as we can go. And the x value in that place is -3. And it's right on the graph. So we're going to use a square bracket. Then we're going to sweep all the way to the right side. So it looks like these two spots are as far to the right as we can go. And they match up with x is 1. But notice open circles. Open circles mean that we use a parenthesis instead of a square bracket. So this domain would be from -3 approaching 1. Finally, the range. So we would only be looking at these values. We go from the bottom to the top. So this is the lowest point on the graph. that means we'd be looking at -2, and it's an open circle. So -2, we're going to use a parenthesis because of that open circle. And then to the top, this is the highest point on the graph, and that matches up with 2, and it's an open circle, so we're going to use parentheses again. So the range would be from -2 to 2.